Hello, good morning everybody. Welcome to the Advanced Data Binding session. I'm Yiğit Boyar.
I'm George Mount, and we're from the Android UI Toolkit, part of the framework team of Android. And today, let's talk a little bit about data binding. All right. So how many of you have used data binding in the past? All right. How many people think it's still in beta? All right, yeah. Yeah, that's the problem. Yeah, we didn't do a great announcement last fall when we released it with Android Studio 1.5. But it is production now, and you are welcome to use it. It's production quality. It's actually doing very well in the public. So if you haven't seen it, I put a little link here for our previous Android data binding talk at Android Dev Summit. And you can just click on this if you're watching at home. That's a great thing to do right now. Pause it and go see that link. And because we're going to show you about 4 minutes, quick version of what we did for about 40 minutes back then.
That's good.
All right. So what is data binding? Well, when we have a layout like this is my awesome store. And what I want to do is, of course, I want to get data into my layout. And of course, I have to find the views that are in my layout and then set the data. Right? This kind of sucks. Right? I hate doing this. So we introduced Android data binding. So let's look at that layout again. OK, we want to get rid of all that setter logic. That kind of sucks. Find view by ID really is lousy. But we have to do something a little different in the onCreate. Instead of calling setContentView, we have to have a different setContent view, which will create a data binding. And then we have to set the data object on that binding. We can't do only that, though. We have to modify our layout just a little bit. First thing we have to do is add the layout tag to the outside of this. And of course, we move the namespace stuff up to the top in the layout tag, because that's the right thing to do. And we have a data tag as well that has all the variables that we're going to use. In this case, it's prod for our product. And that kind of does our import or sets the variables that we're going to use in our layout. And then we also have to reference those. So we assign the values directly to our source or text or anything else that we have in our layout. And here you can see that we can use any expression we want. And it just has the @curly brace to denote that it's a data-bound tag. Let's see how it works.
So I think so data binding looks way too magical, and we want to briefly explain that there's actually no magic. And there's well-defined steps how we prepare that. It's good for you to know, because then you have an idea what's going behind the scenes. If you hit a problem, you have an idea where it might be happening. So when you hit run in Android Studio, the Android Studio starts compiling your application, and it merges your resources. And when the layouts files are merged, we go pick those layout files and then remove everything about data binding. So everything you put there about data binding gets deleted. So if you put layout with something data binding, you lose it. And then the next step, we parse these expressions so that they are grammatically correct. We don't know what you put makes sense or not, but they need to be grammatically correct. So then we parse, we understand, OK, there's some identifiers here. It's accessing a field. We have no idea what that is at this stage, but we know it's correct. And if it's not, we will throw an exception. And next step, your application code gets compiled, like the Java code you write gets compiled. While it's being compiled, we have an annotation processor that gets the outputs from what we parse from the layout files and tries to understand what it means. So let's say you had something like user.admin. Now you declare the variable. We know there was some user class there. We go and find that class. Then we try to figure out, OK, what does isAdmin mean? Is this a method call? Is this a field? We figure that out. We resolve things like, hey, this is a isAdmin method, or you could just say user.admin. We will still understand that there's an isAdmin Boolean method. And then figure out, OK, this grammatically correct expression resolves into a Boolean value. Then we look at the attribute, and we try to find, OK, what is the setter we need to call? Is this visibility integer or enabled, whatever? We resolve it. And all of this happens while your application is being compiled. Once we decide what to do, we write the binders to the actual code that updates the UI, and you profit. So very briefly, this is a like data bound layout file, at the time of compile, we literally do this, like delete everything. We try to keep the files, like the lines match as much as possible. If you go check your build file, you will like find the stripped files. So we get rid of that layout tag. Then we get rid of everything data binding because APT doesn't know about them. We clean them. And then we add some tags so that, go ahead, okay. So that when you inflate the layout, we can understand which view this. This is why, like, even if you don't put IDs on those views, we find them. So right. George has some presents for you.
So that's what we released back in the fall. Let's see what new things we have here. Two-way data binding. Now, I know I've heard a lot from you guys out there that say, this is great, but without two-way data binding is useless, right? I can't believe I heard that, but I think even one-way data binding is pretty awesome. So I saw a few people trying to do their own thing for two-way data binding, and they do something like this, where they do the one-way data binding with the regular data binding field, and then add another handler for the text change, and then they have to check, of course, whether the change really happened, or else you end up with this cycle of loops of the text changes in the field in the view, and then goes back to the field, and it sends a text change message. So it was kind of a mess. And you end up having this change handler for every different bound view in your layout, and it really kind of sucked. So we want to do something a little better than this. Get rid of all that stuff that we used to, and we can do this all on our own by just saying @equals instead of just @curly brace. Right? The @equals is just a kind of a nice, quick, and very visible indicator that this is a two-way data bound field. Now we can bind to the Android text field in a very simple way. Now, you may be wondering, how does this notification happen, right? What's going on underneath the hood? This is kind of important if you're going to write your own data bound fields. So first thing we have to know is what kind of listener should we add. Right? We don't want to use text watcher, right? Because that's only useful for text views or edit text. We don't want to use, I don't know what.
Time change.
Time change, yeah, date change listener or something like that. That wouldn't be good. So we have some kind of generic one. It's called the inverse binding listener. This is basically telling us that there's been a change on your view. And what happens is your binding implements this listener for you. And this is code almost straight out of the generated code. So you can see here that what's going on is it's getting the text from the view, and then it does, of course, null checking, right? You guys have to make sure to do all null checking. Everyone here always null checks their variables, right? Okay, everyone? Yeah.
You're not using data binding, though. You don't need null checks. Yeah. It's 2016.
Yeah, that's right. Who has null pointer exceptions? I don't know. Nobody. And then it finally sets the field. You can see here that it's actually setting this field as an observable field. And actually, you might be interested to see that this comment here is actually in the generated code. So you could, if you want to go look at that generated code, you'll see this comment and see what the inverse of this expression is to help you try to debug if you have a problem with it. So let's look at how you get the field's value. We just saw about getting the field's value. And one thing to do is to try to create this annotation, which will give you a getter for your view. So here we have a text view type, and we want to know what is the getter for Android text. Now we have this method. We can just say declare it. It's a get text. But if you don't supply it, there's a default. And it just uses the attribute name. So even if we didn't supply anything, it would use get text because the attribute is Android text. So it's kind of smart that way. And we have this synthetic attribute. This is for the event. This is the event that notifies that there's been a change in that view. And again, there's a default here. If we didn't supply anything, it would be Android text attr changed. And so most of the time, you wouldn't supply anything here at all. Now I want to talk a little bit more about this. So we, of course, have to get notifications from the text view. And so this is what you'd normally do for a text view, right? You have to set a text watcher. And so we have these event attributes in the binding adapter. And so we just add this other attribute. And we're going to the synthetic attribute. Now, the synthetic attribute, you can't use this in your layout. We check against it. So if you try to do that, it's going to mess up. It's going to throw up a nice exception for you, or error message for you. But anyway, so you can now set this in your binding adapter. And this is, of course, all done for you for all the fields that work. And of course, what you have to do, you have to remove the previous one, and then you have to add a new one. And you have to notify them only if they're not null, right? We don't want to notify null things, because we, of course, want to do null checking. And we also have to notify our onChange lister. So now we know that when that text view changes, it's going to call our generated onChange. Now, if you have a more complex getter, well, this is not very complex, but this is a little bit more complex, right? The text view doesn't return a string. It returns what?
Char
Yeah, char sequence, right? Yeah. And who here uses char sequences? Nobody uses char sequence. If you try to assign a char sequence to a string, typecast error. So this is a little more convenient. So you have a get text string, which will automatically convert your char sequence into a string. And so this kind of thing will help you with that. And again, we have this attribute. And the other field is also there, the event, and it's automatically defaulted. Now, we talked a little about these cycles before, where if you have a text view, or an edit text, and it makes a change, of course, it's going to change your data field. And if you have a change in the data field, it's going to change your edit text. Now, that really sucks, because what happened? User typed A, and now it just set the text on that again, and you lost your cursor.
Yeah, something you will realize, if you set the text on a text view, even to the same text, it will still call the change watchers, it will still invalidate the layout, because inside text view is actually a different spannable string. Like, it has some other format, so we have to do that.
Yeah.
So data binding gets recovered. How is that?
Well, actually, it's going to do more now, because it just recognized that there's another change, and of course, it's going to send another text change, and it's going to keep on going on and on and on. And that kind of sucks. Nobody wants to see infinite cycles in data binding. So let's solve it. We're going to solve it once and for all, right? Well, unfortunately, no. But you can solve it. And we did solve it for all of the ones we've implemented. You just have the check in the binding adapter that says, when you set the text field, we check the previous value and make sure that it hasn't changed. If it has changed, then we'll just set it. If it hasn't changed, then we don't set it. And that breaks the cycle before we can get this kind of infinite loop. Here.
So these kind of solutions we do in data binding, like so changing the framework, that's an option for us, but it will only work in the new devices. By doing these workarounds, we can support data binding, like API 7. Right?
API 7, that's right. Yeah. So does this work on all attributes? Well, no, clearly not. Because we need events. We need events to know whether the field has changed, whether the attribute has changed. And so we only work with the ones that have attribute change events. So like text watcher, like checked changed. So these are external events. These are not on whatever changed events. So the good thing is that almost everything you care about already has a change notification on it. These are the things the user's clicking on, right? They're typing in the edit field. So this is great. So we already have notifications for these, so that will work for almost all the views, all the attributes that you really care about. But if you have your own fuse, you need to do this, have an external event that you can set a listener on. All right, let's talk about a little bit about expression chaining. Now here I have a layout with 3 views, and they all have the same expression in it. It's kind of ugly code. Like, it's all UI code, but it's a little ugly, and I really don't want to do that. I'd like to have it once and then reuse it elsewhere. So what I can do is create an ID that I can later use in my other expressions. So now we can just bind to another field. It's pretty nice. What it's doing under the hood, of course, is just saying, oh, I recognize that one. We already had a bound expression there. I'm just going to substitute that. We also have implied event updates. So you can bind, for example, to a checked field in another view, because checked is a two-way data bind field. So we can just say, oh, look, that field over there was, the user clicked on it, and we get an update right away. We know what happened. Let's talk a little about Lambda expressions.
So two-way data binding is one way of grabbing the data from the layout back to your data model. Another way is the callback, right? Everybody wrote this, you get a view, you set a click listener on that. So we wanted to make it a little bit better. So in today's data, like before we introduce this feature, what you will do with data binding is that you will give the view an ID, and then in your Java code, you will get that ID from the binding. We already create the view for you, and then you will set a click listener on that. So we want to make it more intuitive. We got rid of that. We introduced method references so that you could say, hey, when we know onClick is an event, so where does presenter come from? There's actually another variable you declare, so there's still no magic. It's not like the onClick event you have in the activity, in the framework. So in the presenter, what you would do is, so we'll automatically call this method. You will receive the view because the onClick listener receives the view. You will get the binding. So it's a cool method, like data binding util has a find binding method from any view. And then you will get the item from there and then do whatever you want to do with that. But this was still a lot of unnecessary code. So we wanted to make this a little bit easier. We introduced Lambda expressions. So you get rid of that. You can instead just say, when onClick happens, just call presenter save with the item. Where does the item come from? It's the item that you declared there. So in your save method in the presenter, like you can do whatever you want. Now you have the item. What is very cool, actually, the reason why we push, so we had this in the timeline, but we pushed this feature a little bit earlier because the testing team was releasing these like architectural demos from Google. And for the MVVM demo, they wanted something like this. When you do this, the presenter has 0 Android code. You pass it, so your layout file handles everything specific to Android. You can just test your presenter the way you want. This so beautiful separation, it works very well and makes it very clean. Another very cool thing here is that in Android Studio today, you can go in a, like, roll over the save function there, click on it, and go to the presenter. So much easier to navigate the code while you are developing. So I see, like, let's look at a little bit more details. So it's a Lambda expression. You can also write this, right? The onClick receives a view. So if you look at the description of the onClick callback class, this is how it looks like. So you can actually reference that view in the Lambda expression if you want to use it. And the view inside the expression refers to the one that you declared in the parameter section. It's just like the Java 8 Lambda functions. And now let's say you can actually name it whatever you want. So I name it V. Like the name doesn't need to match anything. So let's look at another example, a focus change. So you want to know when the focus changes, you want to call your presenter with the, whatever the new focus is. Unfortunately, you cannot do this because if you look at the onFocusChange method, onFocusChange class, the method receives the view and the focus state. So even if you don't want to use the view class, the view parameter, you have to declare it. So the rule here is you either declare all of the arguments that the method receives or you declare none. So we figured out not declaring an argument is a very common use case. Like in the click listener, you almost never want the view anyways. So we want to provide that no argument shortcut. Another example here is onLongClick. Now the difference about onLongClick is it actually expects a Boolean value as a result, so that we know we want to populate it or not. So for this to work, the presenter show many method also needs to return a Boolean value. So we are not going to, if you put some Lambda expression there that doesn't return the value expected by the callback, it's not going to compile. We don't want to, it's by default return false, and something breaks in the feature, you have no idea. So if things don't match, we don't try to do magic, we fail. So now there is two ways to do the same thing. There's the Lambda expressions and the method references. They're both useful. I want to go over what the difference is because they actually behave differently. So the major difference between the two is Lambda expressions are evaluated when the event happens. So whatever expression you put there, we evaluate it when user clicks on a button or the text changes or whatever. The method references, on the other hand, is evaluated when we refresh the UI. Like when something is invalidated, when we refresh the UI, we evaluate the expression, we figure out which method wants to be called, and set a click listener that directly references that one. So let's look at the example. It will be more clear. So the previous one where we had the presenter, let's say I set it to null. And the presenter's.save method was linked into the save button. So if you look at save button.get click listener. So in this case, when the presenter is null, does the save button have a click listener? If you are using lambda expressions, no, it actually still has a save button. Like this is not null. Even if you don't have a presenter, there's a callback in that view. But if you are using method references, yes, it's null. Like we don't set it. So sometimes setting a view clickable has side effects and is important for you. You will need to use the method references. But we will take care of null safety. So you're not going to crash even if there's a callback. When the callback runs, we'll figure out there's no presenter, I will just drop it. So the way it works is when you inflate the layout, if you're using lambda expression, we inflate the layout, we set the click listener, it belongs to us, and then when the click happens, we evaluate the presenter, we evaluate the parameters, and then run it. If you are using a method reference, when we execute bindings, this is the method that we generate that updates the UI. When we run that method, we will figure out the presenter, and if there is a presenter, we will wrap it in a listener class, which calls the related method. And if there is none, we set the callback to null. And the listener class we generate looks like just something simple like this. It receives the presenter, so we keep a reference to that one, and then we can call it back. That presenter comes from the presenter we evaluated. Another difference is you can use expressions. This is the one big advantage for Lambda expressions, that you can use any expression inside the Lambda, versus you cannot do that in method expressions. So you can say like, presenter save user's friend, and we will evaluate it. Or you could say like data.presenter. You can use anything that's valid in data binding, you can use it there, and we will evaluate it. Versus in method expressions, you cannot do that, and the method has to match the event, but you can still say like data.presenter's same method. So you can have an expression to the beginning of it, but you cannot change the call parameters. The callback parameters in both of them, you can access it. So if you're using a presenter, you have to declare it yourself, like I want to access the view. So you declare the parameter, sorry, wrong button. And if you are using the method references, it already works, it has to match.
Now you can use a few extra variables now in your Lambda expressions that you couldn't use before. One of them is view IDs. Okay, you can reference your views right in the expression. And it's your view ID, and it's referenced as the camel case-ified version. And this is the same as if you had the same field that you use in your binding. So we camel caseify it just the way we did before. And you can also use the context. We found that many of you wanted to access the context without accessing a specific view. So we just give you the context of the root. And you can use this as a kind of a generated synthetic variable that you can use right there in your layout.
By the way, if you create something that's called context, then we won't do that.
Yeah, don't do that.
But please don't do that.
Yeah, it will override our context if you do that. All right, let's talk about animations. Animations. Everyone wants to use animations in their UIs, right? That's right.
Motion.
Get a little motion in your UI. Well, one of the things you see with data binding is without any kind of special work, you get this kind of weird thing where you click on something and it just pops into place. And that's kind of unfortunate. But we can do something pretty simple to get a nice animation. And let's use transitions. How many of you use transitions before? Yeah, this is something introduced in KitKat. It's very useful. You get kind of automatic animations with it. And what you can do is add this rebind callback, which one of the fields in there, one of the functions there is the on prebind, and that's the thing we really care about. This is evaluated before the binding happens, before the bindings are evaluated. And we don't know what's going to happen. We just know that something is going to happen when this gets called. And what we do is get the scene root, and then of course call the begin delay transition, and then you get a nice effect. Pretty nice, pretty easy, pretty simple.
Maybe we should make this an API. Enable animations.
That's a good idea. Yeah, we should do that. But this doesn't work with everything. Let's look at this add here. When we change the field here, which changes the age of the user, it just still pops in and out. Our transition system doesn't handle every transition you might want, right? It handles the most common ones, changing of the fading in and out, or changing the position of the view, those kinds of things. And you can do your own transitions, but sometimes you want something very custom, and you just want to do an animation for that. So what do? Well, in this case, what we can do is do it with setting. When the value is actually set on the field, we can capture the state there and animate it ourselves. So we create this binding adapter, and we, of course, get the old value and the new value. You don't have to take the old value if you don't want, but in this case, we want it. And then, of course, if nothing's changed, we have to, of course, not do anything. We don't want to do anything if nothing's changed. But then we can just animate the change right then and there. And you can do whatever animation you want. I don't know what you'd want to do on a text field, but you can do whatever you want there. Maybe crossfade, I don't know. Dependency injection. All right, again, show of hands. How many people love dependency injection? All right,
Nice.
all right, this is you guys. This is for you. All right, when you're writing tests, of course, what do? In your binding adapters, you have an if statement. If it's testing settings or you're not testing settings, you can do one or the other, right? But we're dependency injection fans. We don't want to do that. That sucks. So what we do is create a binding adapter that is no longer static. So we have an abstract binding adapter. Of course, this could be an interface. It doesn't have to be an abstract base class. And we implement that interface with your test version or your production version. But we don't know which instance to call, right? We're your data binding. We don't know whether you're going to call something on your test or your production, and so we need to know what you're going to do. So we create this data binding component. Whenever we see an instance method like that, we know that you are going to give us an instance. And so you implement the component. This is a generated data binding component that has that generated getter in it. And you implement that, and you do whatever you need to do to get your component. But then you have to set it as well. So this is the default setter. You can also do it on each inflate call if you want. But probably you only want to use one or the other. But you can do it on every time you inflate a view or bind a view. But you can also do it when you're in your static binding adapters. You don't have to do it just when you're doing instance binding adapters. Now I'll show you an instance where this is useful. So we have this system where we're going to load an image. And we want to load the image using an image loader, right? We have cached already. And we want to get that image loader instance, of course. So we, of course, get the component. But where did that component come from? Well, we could get the context, and then we can try to find it in the context by casting it, and it's kind of a pain. So instead, what we want to do is introduce data binding component. Of course, this is our instance one that we have in our application. And we can introduce it right there in our binding adapter. And then we can use it. If you're using Dagger 2, of course, what you do is you create a module and provide the method. And then you create a component. And you set your default component, just like that. All right.
So by the way, like if you're using data binding but did never write a binding adapter, like play with them, they're amazing. You can create your own attributes. I'm seeing so many. Like we had to create them so we can backport data binding, but they turn out to be like most widely abused in a good way features of data binding. So one question we get mainly is like, how do I start using data binding? Because you already have an app. Like when you start from scratch, yeah, it's very easy. But if you already have an app, it doesn't make sense to rewrite your layouts. It's like, there's unnecessary work. If it works, keep it. But in the new layouts, you can start using data binding. So we wanted to go through these levels. So to start using data binding, you just enable it in Gradle. Super simple, 3 lines. And then one thing you could start doing today in like any new layout you create is get rid of find VA by ID. There is like 25, 30 libraries that try to get rid of find VA by ID.
Oh, now it's 31.
I hope, yeah, I think 31 is the last one. So I have never seen anybody else creating it after we released data binding. This is like something we should have released 7 years ago, or like 8 years, like when we released Android. So you just wrap your layout into the layout tag, and then you're done. Nothing else you have to do. Now in your code, you had these like find view by ID or had these annotations that you put on the views. You get rid of all of it. You get one binding class for that layout, and it already has all the views that has an ID as a field. These are public final fields, and they are type safe. Like you don't need casting. If by mistake, like there's one common mistake happens is you use the same ID in multiple places in different layouts, right? Someone changes an ID in one place, your code doesn't crash because the same ID was used somewhere else. But at runtime, you get a crash because you cannot find the view anymore. With data binding, this cannot happen because we create them per layout. If someone by mistake changes the ID, it's not going to compile. So the second part is binding the UI. This is like very simple way that you can start using data binding. Actually, you should. Like this, in my opinion, it's no-brainer, but of course I'm biased. In every single UI, you have this thing like in your presenter or whatever. Once you load the data, you go through the data, go through your views and set each of them. Like if you need to handle the null, you need to cache them, blah, blah. This is just like so many unnecessary code that you have to write. You don't need to write. So just get rid of those IDs, declare your variable in the layout. Like this is a layout to display with specific information. It's totally intuitive to declare the inputs of the layout there. So you say this layout displays a user. You define it and you use it inside. So when someone inflates your layout and wants to do on it, they already have the binding class, they can see all the setters, they know what the input is for the layout. And on your update UI method, you get rid of all of it. The only thing you do is set it on the binding and it takes care of it. All of this happens without any performance penalty. The third thing is callbacks. Now it's always the case, like you get the binding, you get the fab, and then set the click listener. This is also so unnecessary. Just declare the presenter. Just say like when this button is clicked, call this thing. The nice thing about this implementation is you can just, when you're in Android Studio, it happens all the time, right? Like you're going to a layout, okay, like what happens if user clicks and you try to like search references of that view ID and then see where the click listener is at. There's a couple of steps. Here you can just click and go to that method and find the implementation. So especially if you're starting a new app from scratch, observability might be very, very handy. So instead of having this simple user class, you can may extend base observable. There's also an interface if you don't want to extend. You make it bindable. And then whenever the value changes, you notify this change, and we will take care of updating the UI. And there is this like one of the new features, like highly requested features, two-way data binding. Now, like two-way data binding, when you have like complex model, is not very easy to use. But like all of us have like login forms, like all these simple form kind of layouts that people has to fill. And there's a lot of logic going in there. Instead of writing that code, you can just let two-way data binding handle all of it and return you an object. So for a layout like this, all you need to do is like create a smaller class, make all of them observable field. Like you have only one instance of that class. It doesn't matter how expensive it is. So make everything observable field. And then when we do that, our layout will look like this. So we have a validator that enables, disables the button or whatever logic. And you have the form model. And for each of the input fields, you use them. So you say this is the name. Notice that there's a two-way binding. Or you have a button. You say if my validator model enables it, make it enabled. You do this. So like you cannot do this in every single layout, so you need to be careful. But like something that's like you could encapsulate is about forms or like one place you want to grab data. It's so much cleaner, so much simpler, and you will save time. So you just do this. So now you have a binding layout that gives you an object that has the data, and then you do whatever you want to do with that data. So I want to quickly go through some of the best practices, because data binding is very powerful, but just because there's a way to do things with data binding does not mean that you should do everything with data binding. So something you need to be careful when using data binding is what expressions you put there. So like if you put an expression like this, hey, when user click this button, send the money. you should not do this. Like, they're so wrong because like sending the money is completely about your application. This is your business logic. It has nothing to do with your UI. The only thing you care about is that user clicked on that button. This is where the responsibility of data binding stops. So you get rid of this. Don't do that. Instead, put something like presenter on send click, so that like that presenter class can be tested by itself, and then you will have a reliable application. I know it's not very clear where you want to stop, like how much can I data bind and how much I should do in the Java code. Well, you use your intuition, like, you know, use what works best for you.
So you're saying change the name of our class, our function, right?
Yeah, that was the goal.
Yeah, okay.
Don't call it function. We use program. That was all. Use program. By the way, data binding works with program because we do everything in the compile time. It's the detail. So another thing is like, if it is related to UI, just put it there. I mean, you don't need to, oh my God, I shouldn't put any logic in my examples. It's like, that doesn't make any sense. If it is about how that layout looks, if it is simple, just keep it there, because the important thing is when you look at that layout file 3 months after in Android Studio, then you have an idea what that layout does. That's the point here. Like, they should be they should be declarative. They should explain themselves. But if you put an expression like this there, like there is no way you read it and understand what it's doing, right? It's just confusing. Don't do something like this. They need to be simple expressions. So get rid of it. You know, like create a method that gives a short name, and then use that one instead. Like if they are not readable, like if you realize they are getting long, then you're probably doing something wrong. So it's a method we created.
Yeah, we can also, something to mention though, is we can also do string functions there. So if you want to do string substitutions, you can use the string formatter right there in your expressions as well.
Yeah. So another thing is recycle view. So by the way, 2 days ago we just published like sample application that uses data binding and recycle view on GitHub, and I sent it into the Spaces link so you can find it there. But one thing you need to be careful about is if you're using data binding with recycle view, which you should because it generates the view holder for you. When you bind a view, you should always call execute pending bindings. You should, if you don't do this, binding will defer it until the next layout, and recycle view will get unhappy because the view didn't tell us how, like, what the height is. So there's a couple of things, like these are a couple of little examples that people did with binding adapters mostly. Wanted to mention them. You can do this. This is like HTML. I have a text view and it's an image URL. Well, that should be probably an image view. But it's an image URL. And then it just works. You have a binding adapter, you pass it to there, everything is fine, properly implemented, and you know what that image shows. You don't need the ID or whatever to make it self-explanatory. It's visible. Oh, here is an image here. So you can even have multiple parameters, like binding adapters can receive multiple parameters. You can say, okay, this is the placeholder, and this is the image URL. You have a binding adapter that receives these two attributes. We call it with these two values. We even like convert that drawable into an actual drawable. You don't need to do it yourself. And then you can have your logic. It works very well with testing because in testing, you just provide a dummy adapter that doesn't do anything. And then now all your tests run faster without making network requests. The other thing, font. This has been requested on the text view for many years. We haven't implemented it until data binding. Now, you could just create your own attributes, call it a font, and then it works. There's actually a project on GitHub from Lisa that does this. It's super cool, super convenient. And you can use vector drawables. So now today you cannot use vector drawables in XAML, right? No, if you use data binding, you can actually use vector drawables. You just create the binding adapter for that and do it. Another one here is, like, it's so common in applications. You have dimension like image margin, and then you have something like dimension picture size, and picture margin, so that you can align your views. So you create all these dimensions, you don't need them anymore. You can just use data binding to say, hey, this thing is picture size plus picture margin. That's it. It's like, this should have been there already, but it wasn't. Right, so like, once you start experimenting, like, these are things we did not think about. Maybe the image URL, that was something we thought about, and that was it. Like, people came up with this font, the margin thing, So you get like, it's just new stuff you can do with data mining. So go on, experiment with it. Thank you.
Thank you.